function called determinant of a matrix, and we are going to start with a 2 by 2 matrix first. So we are going to let A, B, C, D will be the entries, and the determinant of a matrix actually is a function, but actually we can simply call it a number. It is a value assigned to a square matrix. So we can only talk about determinant of a square matrix. And the definition for a 2 by 2, first of all, notation is DET, short for the determinant, and you mention the name of the matrix, or you can use the absolute value notation, but that's not the absolute value of a matrix. That's just the same notation, but we call it the determinant of a matrix. Will be simply the two entries AD, you multiply the AD and then minus the BC. So actually it's a difference of two products of the two diagonal entries. So AD minus BC will be the determinant of the matrix A, 2 by 2 matrix. Now, so that is all the notation that I set up for you. You can quote the determinant of the matrix A, and if you put the matrix inside, then you have to use a pair of parentheses, or you can simply use the two vertical lines, borrow from the absolute value notation. So usually I would just stick with the vertical line notation. So it's AD minus BC. So two examples coming right up. Find the determinant of each 2 by 2 matrix. So A is the matrix with 5, -4, first column, 1, 2 in the second. So the determinant of A will be you multiply 5 and 2 and then minus the product of -4 and 1. So I spell out the work for you. So 5 times 2 minus -4 times 1. And common mistake made by students is they don't watch for the signs. So make sure you are going to set up the signs properly. So it should be 10 plus a 4, so it's 14. And that is a value called determinant. 2, example 2, matrix B, -6, 12, first column, 2, -7, second column. Again, determinant of B will be -6 times -7 minus 12 times 2. So it's a positive 42 minus 24, which give you 18. Now, moving on to find the determinant of a higher matrix with the higher dimension will be a little bit hectic. So I will go slow. And so for matrices with dimensions n by n, n will be greater than or equal to 3. We use the method called Cofactor Method to find the determinant. So we start out with a 3 by 3. And we are going to use the first row, and to find the determinant, we use the term to expand. So to find the determinant, we have to identify which row, which column you're using. So we use the first row to expand the determinant. So let me name the entries A, B, C, D, E, F, G, H, I. So again, notation will be determinant of the matrix A. Determinant of, you put the matrix inside the pair of parentheses, or you simply use a pair of vertical lines for the determinant. Then you don't need to spell out the word DET. Now, to expand the determinant using cofactor method, it sounds confusing at the beginning, but once you get the hang of it, it should be easy. Now, first thing, for a matrix, each entry will have a sign, plus or minus, associated to it, with it. And later on, for those of you who plan to take the class called linear algebra, then I can explain more. But right now, to make it simple, it's really easy. The signs will always be the first entry in the first row, first column, always will be a positive sign associated with that particular entry, and then the rest will be alternating. So it's always plus minus plus, first row, second row negative plus negative, and then third row will be plus minus plus. But then if the matrix is 4 by 4, then you have to set up the signs again, but they are all alternating. Now the minus of each entry will be defined as follow. So again, each entry we set up a so-called minor. What is it? is the determinant of a submatrix formed by deleting the corresponding row and column. So I will spell it out for you. So here you go. So for the entry A, okay, you're going to delete, that means cross out the corresponding row, first row, and the first column. Then the remaining entries, and if you take the determinant of it, or of the remaining entries, it will be the so-called minor of A. So I simply copy the remaining entries and set up the determinant for you. B. Again, for the B, is sitting in the first row, so you cross out the first row and then the second column. So the remaining entries D, G, F, I, when you form the determinant, it will be called the minor of B. The third entry is C, so you cross out the first row still, but then the third column. So the determinant of the remaining entries D, G, E, H will be the so-called minor of C. Once you set up the minors, then the determinant of A will be the sum. That means you add the product of, again, each entry will have a sign, positive or negative, and then the entry itself, and then the minor. So you just need to multiply the sign, plus or minus, to the entry, and also to the minor, the determinant, and add them up. So the determinant of A for this particular matrix, now you see that. We're using the first row. So since A, the first entry has a positive sign, so I don't need to spell out the plus. So simply the entry times the minor, the corresponding 2 by 2 determinant. B has a sign minus, so B minus B times the corresponding minor. C is a plus, so C multiplied to the corresponding minor. And now if you're going to, we already learned how to set up the 2 by 2 determinant. So if you write it out, then the determinant of the matrix A will be A times the determinant for the first one is EI minus HF, minus B times the second determinant DI minus GF, plus C times the determinant of the 2 by 2 is DH minus GE. And now if you distribute the ABC, hey, then the determinant of A has 6 terms. AEI minus AHF minus BDI plus BGF plus CDF minus CGE. Now, make sure you don't memorize this as a formula, folks. All you should do is to remember how to set up the minors and set up the determinants. Absolutely no need to memorize this expression as a determinant of a 3 by 3 matrix. But then later on down the road, we are going to shuffle the terms, rearrange them, and then to see how we can rewrite the formula as a shortcut for a 3 by 3 matrix. So let's just simply take a look at 2 examples for a 3 by 3. So example number 3. 2, 3, negative 8 will be first row, 6, 2, 7 is the second, negative 4, negative 1, 5 will be the third row. And we are going to use the first row to expand the determinant. So let's set up the minors. So I set up the 3 matrices for you. So using the first row, 2 will be the first entry. So you cross out the first row, first column. And the remaining entries will give you the minor. 3, second entry in the first row. Cross out these first row and the second column. 6, negative 4, 7, 5 will give you the determinant of the remaining matrix called minor. Negative 8 will be the third entry in the first row, so the minor will be cross out the first row, first column, so you get determinant of 6, negative 4, 2, negative 1. So now the determinant of the matrix, according to the definition or the formula, it will be the entry 2 times its minor, the determinant of 2, negative 1 first column, 7, 5 the second column. 3 has a negative sign, so be minus 3 times the minor is 6, negative 4 first column, 7, 5 third column. Negative 8 has a positive sign, and the minor will be 6, negative 4 first column, 2, negative 1 second column. And now we just expand each determinant. So 2 times the quantity, 2 times 5 is 10, minus a negative 7. Minus 3 times the quantity, 6 times 5 is 30, but minus a negative 28. And then minus 8 times the determinant will be negative 6 minus a negative 8. So you change it to a plus 8. And make sure you watch the signs. So that's why I highlight, okay, the signs. So 2 times first one should be 10 plus 7, so be 17. Minus 3 times 30 plus 28 is 58. Minus 8 times 2. So you have 34 minus 174 minus 16. So the determinant will be just a number negative 156. Of course, the natural question next one will be, can we use a different row or a different column? Well, let's try it. So suppose we are going to use the second column. If you do, then we will set up the minus the same way. So second column, first entry is 3. Cross out the first row, second column, so the minor will be the determinant of 6, negative 4, 7, and 5. 2. Second entry in the second column, so cross out the second row, second column, so the minor will be 2, negative 4, negative 8, 5. Negative 1, the last entry in the second row, so you second column, cross out the third row and also the second column. So 2, 6, negative 8, 7 will be give you the minor. Now, next step is extremely important. You need to set up the product. Since 3 is a second entry in the first row, so the sign is negative. So I highlight the sign negative. So be negative 3, the entry 3 times the corresponding minor. 2 will be plus, because if you walk yourself through the sign, plus, negative, plus. So 2 has a plus sign. The minor will be determinant of 2, negative 4 first column, negative 8, 5 in the second column. But the third entry in the second column will have a negative sign. Plus, minus, plus, minus. So that's why you highlight the negative for the negative 1 and times corresponding minor. So work it out. Negative 3, 6 times 5 is 30, minus a negative 28. That actually gives you a positive 58. 2 times the quantity, 2 times 5 is 10, but minus 32, which gives you negative 22. 2 times 7 is 14, minus a 48, negative, so be plus, so be 62. So you should have negative 3 times 58 plus 2 times negative 22, but plus 1 times 62. So add them together, now you know you get exactly the same thing. So the question that you asked earlier, can you use a different column? Yes, absolutely. I also will show you how to use your calculator. So again, calculator demo. Of course, you should enter your matrix. So by now you should know how. So second matrix, go to the edit, hit enter, but don't forget to change the size to 3 by 3. Enter the entries 2. Enter, the calculator will go across, so be 3, negative 8. 6, 2, 7. Negative 4, negative 1, and 5. Okay, go out to the calculation screen, and the first thing is always try to pull up your matrix to make sure you have the correct entries. 2, 3, negative 8, 6, 2, 7, negative 4, negative 1, 5. Perfect. Now, how to get the determinant is the second matrix. Go over to the math. First item is your determinant, folks. And you pull up the name of the matrix, A, close the parentheses, and when you hit that button, enter, negative 156. But of course, you use this for checking. So do not just give the answer negative 56 without showing the work. I don't think your teacher will give you any points. Okay? For my student, if they do that, I will just give them 1 point if the answer is correct for no work. So here you go. And I also did this screenshot. and I will pull it up later. So next example, let's try another one. So if you know, then pause the podcast and do this on your own. Come back and then listen. Okay? So here you go. This time I will use a different row, so I will use the third row and set up the minus. So 7, cross out first column, third row. You have the remaining entries for the minor. 9, cross out the third row, second column. Remaining entries will be the minor. 10, cross out the third row and the last column. Remaining entries will be the minor. See? It's getting easier each time. Then set up the determinant. The signs for 7, 9, and 10 will be plus, minus, plus. So 7 starts with a plus, then 9 will be the negative, and 10 will be the plus. Copy down the remaining entries, set up the determinant. It's easier, okay, to see the determinant and don't just, look at the matrix. So you have what? Negative 4, 2, first column, negative 1, negative 3, second column will be the minor for 7. Determinant of 3, 0, first column, negative 1, negative 3 will be the minor for 9. Determinant of 3, 0, first column, negative 4, 2, second column will be the minor for 10. So here you go again. 7 times. Negative 4 times negative 3 is 12. Minus a negative 2 is a plus 2. So you should have 7 times 14, which is a 98. Minus 9 times negative 3 times 3 is a negative 9. Minus a 0. So negative 9 times negative 9 is a plus 81. 10 times 3 times 2 is 6 minus a 0. So 10 times 6 is 60. Add them up, you get 239. Okay. But of course, you should try using a column. Say using the first column. Let's set up the minor. First column you have 307. So 3, the minor, cross out first row, first column, you get 2, 9, negative 3, 10. 0, cross out the first column, second row, you get negative 4, 9, negative 1, 10. Cross out the first column, last row, you get negative 4, 2, and negative 1, negative 3 will be the minor for 7. Signs, plus, minus, plus. So you have 3 is a plus, 0 is a negative, and 7 is a plus. Here we go again. 3 times determinant is 2 times 10 is 20, minus a negative 27, so it's a plus. So you have 3 times 47. Hey, second entry is 0. Good news, so you don't need to calculate. 7 times negative 3, negative 4 will give you 12, minus a negative 2 is a plus 2. So 7 times 14 give you 98. Add them up. Here you go, 239. Screenshot. Perfect. Enter the matrix A and use the determinant function, 239. And you can extend the concept to 4 by 4, 5 by 5. So this cofactor method works for all sizes. Okay, thank you. We are going to look at how to figure out the determinants of a matrix, especially if the matrix is of size more than 3 by 3. And we are going to learn a method called Cofactor Method, and which is a you can learn the details of the method when you pick up the linear algebra class down the road. Right now I will just explain how to use it. So we are going to consider a 3 by 3 matrix, and to find a value associated to a matrix is called determinant. And the way to find it is it depends on which row or which column you're using. But actually it really doesn't matter which one. So if you just make up your mind, for example, we are going to start, we are going to use the first row. So the language that we are going to learn to use is we are going to use the first row to expand the determinant. And the way to do it is, say the first row you have entries A, B, C. For each entry each entry will be associated with a term called minor. And minor actually is a determinant of a submatrix formed by deleting, that means take away, the corresponding row and column. So what I mean by minor for the A is the following. Okay, so if you're going to use A, the minor for the A will be you're going to take out the row corresponds to A and the column corresponds to A. So the remaining submatrix will be EFHI, and you just need to take the determinant. B, if you're going to look at B, so B will be my next one. And let me change my color. So if it is B, you're going to delete the row for the B and the column for the B. So the remaining submatrix will be DGFI. DGFI. And you set up the determinant. Okay. And now for the C, you're going to delete the row for the C and the column for the C. So the remaining matrix will be DEFGH. So this way, after you set up the minus for each entry in the row that you are using, then the determinant of A will be the following. Will be always the entry, because the row that you pick will be the first row. So it's always the entry A times the corresponding minor, and B times the corresponding minor, and C times corresponding minor, but then you need to either add or subtract. So turns out if you start from, and also one last thing is each entry will be associated with A to a sign, plus or minus. And the first entry in the matrix A is always a plus. So you just have to count the signs, and they change plus minus in the alternate form. So plus minus, and so on. So A will be positive and B will be negative and C will be positive. So the determinant of A will be defined in such a fashion. Now, if we are going to multiply expand the 2 by 2, because we already know what to do with 2 by 2, then the determinant of A will be the entry A times EI minus HF minus B times the quantity DI minus GF plus C times the quantity DH minus GE. And you just distribute A, B, C. So the determinant actually will be the 6 terms that we are seeing. If you are going to use a different row, different column, actually you can backtrack. So it's still the same 6 terms. So it just depends on which one, which row or which column you're using. So the idea will be the same. So this is called the Cofactor Method. And the Cofactor Method works for 3 by 3, 4 by 4, 10 by 10, any sizes using this way. But the higher the dimension of the matrix, the size, then the more tedious will be the process to find the determinant of the matrix. So let's try one right away. I set up a matrix called 2, 5, 6, negative 3, 1, negative 4, 1, negative 7, 1, and I said use row 2. So if you use the row 2, okay, so the entry will be negative 3, and I set up for you, so it's a negative 3, and the minor will be, you cross out the second row, first column, so the minor will be 5, 6, negative 7, 1. And then the entry is 1. So you cross out the second row, second column. So the submatrix will be 2, 1, 6, 1 right here. Negative 4. Cross out second row, third column. You get 2, 5, 1, negative 7. How about the signs associated to each entry? 2 is plus. So negative 3 is a minus. So 2 negative plus negative. So that's why negative 3 you put a negative in front and then plus and negative. And now you're going to simply expand the 2 by 2. So double negative 3 will be positive 3. So 5 minus a negative 42 will be 5 plus 42, which is 47 times 3 is 141. 2 times 1 is 2 minus 6, so it's a negative 4 times a 1 is a negative 4. 2 times negative 7 is a negative 14 minus a 5, so it'll be negative 19 times a positive 4, so it'll be negative 76. So 144 minus 4 minus 76 is 61. Okay. Another example. And 7, negative 1, 2, 0, 6, 1, negative 4, 5, negative 3. I said use column 1. So if you use the column 1, write out the entry 7, 0, negative 4. and then you are going to cross out terms. Sooner or later, you don't need to show yourself all that work, but the first few times, they make it really visually more easily. So 7, cross out the first row, first column, so the remaining submatrix will be 6, 1, 5, negative 3. 0, cross out the first column, second row, so negative 3, 2, 5, negative 3. 4, so the submatrix will be negative 3, 6, 2, 1. Signs, because I'm using the first column, so 7 is a plus, negative, plus. So plus, negative, plus. And you expand the 2 by 2. So 6 times negative 3 is a negative 18 minus a 5, so it will be negative 23 times 7 is negative 161. 0 all goes out. Negative 3 times 1 is negative 3 minus 12, so it will be negative 15 times a negative 4 is a positive 60. So the answer is negative 101. Okay. Example number 3, using the third row, 5, negative 9, 7. Cross out the first column, third row, so the submatrix will be negative 1, 8, 3, negative 4. Negative 9, cross out third row, second column, you get 2, negative 3, 3, negative 4. 7, cross out the third row, and 7 actually should be the middle column. So wait a second. Just fix it. So 7, you cross out the third column's last row, so you get 2, negative 3, negative 1, 8. And then signs, because you're using the third row, so plus, minus, plus. So the sign will be plus, negative, plus. So plus, negative, plus. So you have negative 1 times a negative 4 is 4 minus 24. So negative 20 times 5 is a negative 100. Negative 8 plus a 9 is a 1 times 9, which is a 9. 2 times 8 is 16 minus a 3. So it'll be 13 times 7 is a 91. Whoops, when you add them up, turns out to be 0. The determinant is 0. Okay. Another example, 4 by 4. Whoa. Well, the method will be the same. It's just a little bit more tedious. Why? You will see. I said use column 2. And the reason why you pick column 2 now is because you have 2 entries with the zeros. So from now on, you don't just use column 1 or row 1. You try to use the row or column with the most number of zeros. So that's why I picked column 2 for you. So if you pick column 2, write down the entries 1, 0, negative 2, 0. And learn to do the submatrix. So cross out the 1, cross out the first row, second column. So the remaining entries before negative 6, 1, negative 3, 0, negative 1, negative 1, 8, 3, right here. Second entry, cross out the second column, second row. So it'll be negative 2, negative 6, 1, and so on. But then it's a 0. Oh, so I didn't even write it down. And then 2, negative 2. So cross out the third row, second column. So you have negative 2, 4, 1 right here. 5, negative 3, negative 1, 2, negative 1, 3. Last entry here is 0, so I don't bother to write down the submatrix for you. Signs, plus, negative. So the first entry starts with a negative. So that's why it's negative, plus, negative, plus. Now you have 2 chances to use the cofactor for the 3 by 3. So that's why it's tedious. Now you know. So for the 3 by 3 here, I keep track of the negative 1, but put up a big bracket to keep track of the 3 by 3 determinant. And now, as you can see, I'm using the second row. Or you could use the second column, but I use the second row. So negative 6 times the submatrix, plus 0, minus 8 times the submatrix. Why negative in front of the negative 6? Plus, minus. So the negative 6 is a negative. So negative plus negative. Next one, double negative times a 2 is a 2. So for this matrix, it doesn't matter which row, which column. You don't have any zeros. So as you can tell, I use the first row. So it'll be negative 2 times the corresponding submatrix, minus a 5 times the corresponding submatrix, plus a 2 times the corresponding submatrix. And now just really carefully Okay, as you can tell, I'm very careful in copying down the steps. So this will be double positive, negative will give you positive 6, negative 9 minus a 1 right here, negative 8. When you multiply negative 4 plus a 3 right here, plus 2 bracket, negative 2. So this is negative 9 minus a 1, minus 5 times 12 plus a 1, 2 times the quantity, negative 4 plus a 3. So make sure you keep track of all those numbers, and the final answer will be negative 42. So now, of course, you say, gee, how do I know I have a correct answer? Well, you should know how to answer your own question. Is either you pick another row, another column to repeat, or calculator time. So for the calculator, you are going to, I will use this as an example. You go to the second matrix, go over to the edit, and since your A is 4 by 4, so you enter 4 and hit enter, enter 4, so that's the size. And I already put the entries in for you. And now you're going to, go out to the calculation screen because you're looking for the determinant. So where's the determinant key? Second matrix, go to the math. First one, determinant. So you hit enter, so the calculator will get you the determinant, but you need to put in the name of the matrix. So it'll be second matrix, and I store it under A. Close the parentheses. When I hit that enter key, what do you think? What's the answer? Negative 42. Folks, now you know. So I already did the screenshot for you. I also have the answer for you. And for the other problems on the other page, for example, number 2, I did this, store the matrix for you, and the determinant was negative 101. Second example, I store the matrix for you, and the determinant is 0. So folks, you don't really need a book nor any additional material. Just make up your own matrix, walk through the cofactor method, practice the number, and use your calculator to check the answer. Same thing for the first one. I believe I also have. This one is also only theory. Oh no, I have the screenshot for number 1 also. That's the matrix. And the answer is indeed 61. Okay. So again, I set a lecture for you. It should be a full lecture to walk you through from the theory to the exercises to the calculator. So things should never go wrong. And I will give you more example in the next podcast, also on determinant. And you will see why we need to learn determinant. So stay tuned. Quote unquote, see you in the next one. We will look at only a 3 by 3. And we still use the cofactor method to set up the determinant. And we are going to see if there is a shortcut somewhere. So the first thing will be let A, B, C, D, E, F, G, H, I will be the entries of the 3 by 3. We already know how to use the cofactor method. So let's stick with the first row, using the first row to expand the determinant. So A, B, C will be the entries. So we know that the determinant of the matrix A will be A times the corresponding submatrix. So you cross out the first row and you cross out the first column. So you end up with E, F, H, I will be the submatrix for the entry A. B times the submatrix for B is cross out the middle column. So it'll be D, G, F, I for the B. Cross out the third column, D, E, G, H, D, E, G, H. So the determinant will be A times the corresponding submatrix minus B times the corresponding submatrix plus C times the corresponding determinant. I mean the determinant of the submatrix. So now We are going to expand the 2 by 2. So the determinant of A will be A times the quantity EI minus HF minus B times the quantity DI minus GF plus C times the quantity DH minus GE. And now we can distribute the ABC. So we have AEI, AHF, BDI, BGF, CDH, and CGE. And all I'm doing now is to simply group the 3 positive terms first, then the 3 negative terms. So I put AEI plus BGF plus CDH and minus CGE minus AHF and minus BDI. And if you look at the original determinant again and copy the first 2 columns, put them on the side, hey, there is a pattern. Turns out AEI is like the product of the entries along the first diagonal. BGF will be the entries along the second diagonal. CDH, the third diagonal, and they are all positive. If you go the other way, CEG, okay, and then AHF and BDI, and they will be negative. So this will be the shortcut method. A lot of engineering students will use this method to figure out the determinant. But this method only works for 3 by 3. And why not 4 by 4? Hey, try it then. Just like what I just did. Use the cofactor method, expand the 4 by 4 and see if you can find pattern. Most likely not. So let's for this particular podcast, we are going to use the shortcut method then. So the 3 by 3 will be 2, negative 3, 1 first column, 5, 1, negative 7, 6, negative 4, 1 will be the 3 by 3 matrix and the determinant. Now we copy the first 2 columns and put them on the side. So the shortcut method will be the following. You're going to carefully, okay, sometimes you can just eyeball the numbers. Sometimes you might, the first time maybe you can draw the line. So you multiply 2 to 1 to 1. That's your first group. And then you multiply 5 to negative 4 to 1. That will be your second group. Third group will be 6 times negative 3, negative 7. And you add them up. Now you can go the other way. Will be 1 times 6 will be the next group, but it will be minus, negative. Minus negative 7 times a negative 4 times a 2. Minus 1 times a negative 3 times a 5. So now all you have to do is to multiply the numbers. So it'll be 2 minus 20, and then plus 6 times 3 is 18. 18 times 7 is 126. Minus 6, and then minus 7 times 4 is 28 times 2 is 56. Triple negative, so it'll be still negative. And then plus 3 times 5 is 15. So if you add them up, it's 61. Okay. Again, how do you know is the correct answer? Hey, you can use the cofactor method to expand, or you can also use the matrix. So I already took the screenshot of the matrix and then the determinant function. Here you go, 61. Okay, so we know that we get the correct answer. 2 more examples. So actually you should stop the podcast, do the problem, and come back and then check the answer. But I will continue. So again, what you're going to do with number 2, same thing. I just set up a general 3 by 3 matrix to let you practice. Okay, so let me get away from that one. So again, stack the first 2 columns nicely. And you're going to multiply numbers along the diagonal. So 7 times 6 times negative 3. First bunch. Negative 3 times 1 times negative 4. 2 times 0 times 5. You know, that will be 0 later on. And then minus the other group. Negative 4 times 6 times 2. minus 5 times 1 times 7, and minus negative 3 times 0 times negative 3. So you know this will drop out also. So 7 times 6 times negative 3 is a negative 126. 3 times 4 is 12, but it's positive, plus a 0, and then plus 4 times 6 times 2 will give you 48, minus 35, minus 0. So the answer is 101, negative. Okay? So again, I did the screenshot of the calculator, put in the matrix, and also the determinant is negative 101. Number 3, again, there was really no special, nothing special about the matrix, just to give you extra practice. So you should stop the podcast, do the problem, and then come back and check the answer. So again, stack the first 2 columns on the side, and you start multiplying 2 times 8 times 7, negative 1 times negative 4 times 5, 3 times negative 3 times negative 9 will give you add them up, minus 5 times 8 times 3, minus negative 4 times negative 9 times 2, minus 7 times negative 3 times negative 1. So, in fact, you can run your calculator, and turns out the determinant equals to 0. Again, I put the matrix into the calculator, and the determinant is indeed 0. And you should also always try to use the cofactor method and double check the answer. So I hope you enjoyed this little shortcut. But again, warning, it's only good for 3 by 3 matrix. Thank you.